Hello, this is Brian Purdy with the Florida Aviation Network. Today, once again, at the NBAA convention in Orlando, NBAA 2022. Today, we're with Martin Peryea of Jaunt Air Mobility and standing in front of the Jaunt Journey aircraft. We're going to discuss its future and its capabilities. Welcome to NBAA.
Yeah, thank you, Brian. I really appreciate the time here this afternoon.
Well, I am totally enthralled. I think you guys may have had a model here several years ago.
We did. We actually formed the company in 2019, and we've been developing the aircraft configuration over that period of time. And we are developing a all-electric aircraft for the urban air mobility market, basically an air taxi system that's capable of moving passengers and cargo.
Okay, great. And it's almost a familiar design. It's not those small rotors, for the lift. We got a nice big one. So tell us how the safety advantages of that.
Yeah, we have a unique aircraft configuration compared to some of the other companies that are using multi-rotor systems. We are designing an aircraft that's utilizing the slowed rotor compound technology that was being developed by Aviation. Jaunt acquired all of the patents and the design know-how for the SRC technology, which utilizes a large single main rotor sitting on top of the aircraft for that vertical takeoff and landing aspects. The rotor slows down in flight and the aircraft becomes wing-borne. It basically is flying just like a fixed-wing airplane that gives you the ride comfort of a fixed-wing airplane. And of course, the rotor vibration, rotor noise disappears as a result of that. But what it offers in terms of the safety, as you had asked about, is the ability to continue a safe flight if you lose all of your electrical power on the aircraft. Helicopters have the ability to auto-rotate. We've designed in some extra capability into this rotor system so that you can auto-rotate from any altitude and any airspeed safely to the ground.
We didn't even have to worry about a ballistic chute like most others are having to use.
Yeah, that's correct. A ballistic chute, helps you if you're at high altitudes and relatively low airspeeds. They don't help you if you're close to the ground because of the time it takes to deploy, and you can't control a ballistic chute. You can't choose where you're going to land. In our particular situation, we can actually fly the aircraft to a landing spot and come down with actually zero forward airspeed.
So at least we know we're going to complete the flight the way we started it.
Yeah, that's exactly right.
Okay. So also some of the changes from the quadricopter, you've actually made the rotor fully powered all the time. What all went into that decision?
Yeah, so the requirement to serve in the urban area, in and around the city and so forth, required the ability to actually have the helicopter-like capabilities where you can take off and land vertically and even come into a hover and hover over a spot for a period of time while, assessing the situation there. And so what allowed us to do that was really the electrification activities that are taking place in the aerospace industry. A lot of aircraft configurations now are coming about because of the ability to power these motors, if you will, with electrical power, the propellers and lifting devices. And so we were able to control the rotor because it's electrically driven throughout its entire flight envelope to optimize the performance of the aircraft.
That's great, because that way you can control your rise and your descent a little bit all the way through. Okay. Since we're sitting here in front of a model, would you like to point out anything in particular? We can walk around.
Yeah, what's kind of unique about this aircraft, it looks like a helicopter and it looks like an airplane, but we made some great design changes over a typical helicopter. A helicopter has a tail rotor. Tail rotor is the second largest noise generator on a helicopter, and so we've eliminated the tail rotor in the back of the aircraft. The tail rotor is used for yaw control, anti-torque control. We do that with our wing-mounted propellers that we have on the aircraft.
Well, if you'd like to take the microphone, and then we can
Yeah, sure.
get out of the way.
Okay, all right, perfect. Yeah, I just pointed out here, I'm standing in front of the aircraft here on the right side of the aircraft, and you can see two propellers that are mounted out here. Separating the propellers like this actually provide redundancy in terms of bird strike type of issues that you may run into, but it also provides redundancy when you're in a hover for the yaw control. So from electrical power perspective, if you were to lose like one of your main battery systems, you still have the ability to control the aircraft in that low-speed flight regime. Also, it also provides that redundancy when you're flying like an airplane. So you have that capability. So you got two on the right side of the aircraft, two on the left side of the aircraft. Again, I don't know if you can see in the back, but there isn't a tail rotor there in the aircraft. It looks just like a tail that you would find on an airplane. It does have conventional airplane controls, a rudder, an elevator, and the ailerons. And so the pilot, feels like he's really flying a conventional airplane at that time.
I know when I first had a gyrocopter ride, I thought I was more in a fixed-wing aircraft. Is it very comparable to a gyrocopter as far as the controls on that for this one?
Yeah, the controls, there are two sidearm controllers, so you don't have a conventional like cyclic stick, collective stick that you would find in a helicopter. Because it is a advanced flight control system, we're utilizing what we call fly-by-wire. The computers are actually flying the aircraft. The pilot is really commanding the aircraft. If he wants to climb higher, he pulls back on the stick. If he wants to fly faster, he pushes forward on the other stick. And so it's more of a command type of control system. And so it's almost seamlessly, going from that slow speed, take off vertically, and then transition into forward flight. Advanced, very, very advanced control system that allows you to do that. And you can only do that because of the advanced flight control systems with the fly-by-wire system.
So that begs the question, when you have pilots for this, are you looking more for people with helicopter experience, more with fixed wing, or we're going to take people with both or neither and build it up?
Yeah, that's a good question. And so we have the ability to certify this particular aircraft under existing rotorcraft rules, helicopter rules. And so if you're a helicopter pilot, you can fly this aircraft without any additional, training per se, other than being familiar with the avionics systems and some of the unique features. Conventional airplane pilots will need to undergo some additional training, with the vertical takeoff and landing features of a helicopter pilot before they can be, certified to operate the aircraft.
Okay, great.
Yeah.
We were talking about the exterior or the engines. They're only like 80 horsepower each.
Yeah, the propellers are sized for cruise flight. We fly about 150 knots really comfortably, and so each of the propeller electrical motors are about 80 horsepower each, and so we have four on the aircraft providing that power for that cruise flight condition.
And it seems, since all the lift off the ground was used by the upper rotor, the wings were particularly configured for efficient horizontal flight.
Yes, that's exactly right. Since we don't really take off and land like an airplane that requires, large wing areas, through flaps, we don't have flaps on this aircraft. And so our aircraft wings are more like sailplane wings. They're what we call high aspect ratio wings. They're long and they're skinny in that sense. And that improves the aerodynamic efficiency of the entire aircraft as a result of that.
And well, you've got longer duration because you got the same batteries, and like I think we were talking, the hover capability is going to be the most intense energy use. Tell us more about the tilt rotor portion of the aircraft.
Yeah. So, a large single main rotor actually is the most efficient lifting device, created by man, if you will. The more area, the bigger the diameter, the more efficient it is. And so we have a large rotor for that great efficiency for the aircraft. And that greatly improves the battery life and the cycle time on the battery itself. And as a result, it lowers the operational costs and the maintenance costs associated with battery replacement. And that does give us a big differentiator with some of the other eVTOL configurations that are out there that require more power to hover and higher demand on the battery system, which has a tendency to impact the life of the battery of the aircraft itself. And so, the aircraft is really designed as an air taxi, doing that short flights back and forth all day long. And while you're loading and unloading the passengers, you have that opportunity to recharge the aircraft. So it takes about 6 or 7 minutes to provide that charge to the aircraft so that you can continue that service back and forth. Yeah.
So we were talking about the level flight technology that you've got developed, that way more comfortable flight for the passengers. Tell us a little bit more about that and how it was brought about.
Yeah, the level flying technology is patented technology that we developed to allow the passengers to actually remain level throughout the entire flight envelope. So when they take off and go into cruise flight, and when they land, the orientation of the airplane, the passengers remain level the whole time. Unlike a traditional helicopter that has to really tilt over their nose quite a bit to get that forward speed going, and when they're landing, they pull the nose way up, and so it is unsettling sometimes for the passengers to kind of feel that motion.
I know from my flying helicopters that was the fun part, but oh well. And I guess and part of it's because of the tilting.
So we have this system on the aircraft. If the audience can see it, there is a vertical mast that runs. Let me get on this side here. That runs up and down. And this mechanism right here moves fore and aft a little bit. It doesn't take much to adjust the CG of the aircraft.
And is that automatically done by the computers also?
It's automatically done by the computer system. So the computer senses, the orientation of the aircraft and will make that slight adjustment. The pilot doesn't need to worry about it. It's done automatically for them. And so it does actually make piloting the aircraft a little easier as a result of that, because he doesn't have to worry about these tilting motions that they typically go through.
During the worst case with auto rotation, is it fixed wherever it happened to be last, or does it?
So we optimize that also in auto rotation. So people that are familiar with helicopter auto rotation procedures, there's a lot of motion that takes place in the aircraft itself. And so that motion, takes place with the tilting mass. So again, that the airframe kind of remains level throughout that entire auto rotation event. Okay. The other nice aspect of this level fly technology is when the aircraft is configured for moving cargo, you can put the cargo anywhere in the aircraft and not have to worry about being outside of its center of gravity range, the CG range of the aircraft. The flight control computers automatically sense that loading condition and will make the necessary adjustments. So when you load the aircraft, you don't need to worry about whether you got the load up front or the load in the back. It automatically compensates for that loading condition.
Within the ranges that...
Yeah, within the physical range of the aircraft itself.
Oh, okay.
Yes,
right.
yes.
Got the whole cargo area to do what you please.
Yeah, weight and balance is definitely problematic, certainly for smaller aircraft. Even for larger aircraft, but they have much more capabilities, built into the aircraft. Mm-hmm. But for smaller aircraft, it's something that the pilots need to pay really close attention to when they're loading, passengers or cargo onto the aircraft.
Okay, great. I'm looking forward to the design. Understand that there's hybrids in the future for it, and a good market for it. So hopefully we'll see growth in the company and in the variation of the Jaunt journey to the Jaunt excursion or something.
Yeah, thank you, Brian. I appreciate it.
Okay. Well, thank you. This is Brian Purdy with the Florida Aviation Network with Martin Peryea of Jaunt Air Mobility at NBA Convention 2022. Have a great day.
Thank you.
Thank you.
Thank you.